The algebra of matrices. A matrix is a method of organizing data into rows and columns. For example, the matrix -1, 3, 7, 0, -4, 2 is made of 2 rows and 3 columns. The rows go across. The columns go up and down like the columns on a house. And so the way we write the dimensions is that we say it is a 2 by 3 matrix, rows first and then columns. There are many fields in technology that use matrices to store and manipulate data. Cameras use a 3 by 3 color correction matrix to improve photos. Robotics and computer graphics use matrices to manage movement of objects. Businesses use matrices to analyze data about their customers. And there are entire college courses, such as linear algebra, that are devoted to learning how to work with matrices. But this section is just a really brief, basic introduction. So we're going to start out with addition of matrices. For matrices to be added or subtracted, they first must have the same dimensions. So these matrices are both 3 rows by 2 columns. So if they're the exact same dimensions, they can be added or subtracted, and if they're not, they cannot. And then you simply add or subtract the entries that are in the corresponding positions. So to add these 2 matrices, for example, I would add 5 plus 0. Those are both in the upper left-hand corner. And then I would add -1 plus 6, 7 plus -5, 0 plus -3, -3 plus -7, and 2 plus 1. Be very careful if it's subtraction that you watch your signs. Scalar multiplication, and I misspelled scalar there, sorry, that should be an A right there. Scalar multiplication is when a number is placed outside of the matrix and you simply multiply it times every number inside, and that outside number is called a scalar. And so I just basically multiply 2 by everything inside, and I end up with -6, 14, 2, and 8. So it scales the matrix. It makes it larger or smaller. Now, multiplying 2 matrices together is a bit complicated. The first thing you have to figure out is if it can even be multiplied at all. So write down the dimensions underneath each matrix. This first one is a 2 by 2. And the second one is a 2 by 3, 2 rows, 3 columns. The way you can tell if they can be multiplied is that the 2 inside numbers here, when you've written down the dimensions, those 2 numbers must be the same. If they're not, you can't multiply them. So the columns of the second matrix have to be the same as the number of rows in the columns in the first matrix has to be the same as the number of rows in the second matrix. And then these outside numbers give you the dimensions of your answer. So our solution will be a 2 by 3 matrix. So I just go ahead and mark up a 2 by 3 matrix and put little blanks where the numbers are going to go. So what we do first is we start on the first row and we multiply it by the first column. It's always rows times columns. And I keep moving my numbers. I multiply 5 times 1 plus 0 times 0. 5 times 1 plus 0 times 0. And that's going to be 5. And so that goes in the first spot. Then I stay on the first row, move over to the second column, and I'm going to do 5 times 4 plus 0 times -1. 5 times 4 plus 0 times -1 comes out to be 20. Stay on the first row, move to the third column. It's going to be 5 times negative 2 plus 0 times 9. 5 times negative 2 plus 0 times 9 comes out to be negative 10. Now I've multiplied the first row times all the columns. I drop down to the second row and multiply times all the columns. So it will be negative 3 times 1 plus 1 times 0. Second row, first column. Negative 3 times 1 plus 1 times 0 would be negative 3. Stay on the second row, move to the second column. Negative 3 times 4 plus 1 times negative 1. Negative 3 times 4 plus 1 times negative 1 is negative 13. And then finally the second row, third column. Negative 3 times negative 2 plus 1 times 9. Negative 3 times negative 2 plus 1 times 9 would be 15. And then it's multiplied. So let's do another one. First, let's check and see if it can be multiplied. This first matrix is a 3-row, 2-column, 3 by 2. And the second matrix is a 2-row, 1-column, 2 by 1. So these two inside numbers closest to each other have to be the same, and they are. And then my answer is going to be these outside numbers. It's going to be 3 by 1 dimensions. So 3 rows, 1 column would look like that. I start with the first row multiplied by the first column. It's going to be negative 6 times 8 plus 3 times 10. Negative 6 times 8 plus 3 times 10 comes out to be negative 18. Then we move down to the second row times our column. 2 times 8 plus negative 1 times 10. 2 times 8 plus negative 1 times 10 is 6. Drop down again. Third row, first column. 0 times 8 plus 4 times 10. 0 times 8 plus 4 times 10 comes out to be 40. Matrix multiplication is not commutative. What I mean by that is the normal commutative property for multiplication says A times B is equal to B times A. It says if you switch the order in multiplication, you'll still come out the same. 2 times 3 is the same as 3 times 2. However, for matrices, it's not true. If you reverse the order, you could get a different answer or even have a problem that's not even possible to multiply. So this commutative property for multiplication does not apply to matrices.